Hello, in lesson 3.1, we talked about how different mixtures can be broken down into substances or compounds and then further down into their elements. In this lesson, we're going to clarify the definition between a molecule and a compound, and we're going to talk about how we can represent molecules in a written formula, just to make it easier for ourselves to draw different types of molecules or compounds. So, again, in the last lesson, when we're talking about substances, it's what we see with our eye, right? Usually it's like a bulk substance, so a whole bunch of molecules or compounds combined together. Now, you might have heard the two terms molecule and compound used interchangeably, but there is a slight difference between the two definitions. And let me give you an example by looking at this image on the left hand side to compare the two definitions. So here we have examples of all molecules: H2, O2, Cl2. On the right hand side of this image, we see two examples of things that we would specifically refer to as compounds: H2O and HCl. So go ahead and take a moment and pause this video if you have to. Can you tell the difference right now between a molecule, this stuff, and a compound, this stuff? Okay, so you might notice that molecules can be made of the same elements as long as they're combined or bonded together chemically, right? So even though these two elements are the same, they're both H's, they're combined chemically, so we can consider that a molecule. A molecule is a group of two or more atoms held together by chemical bonds. That's the formal definition. So as long as I have two elements, they could be same or different, and they're combined together, that is a molecule. Noticing the compounds here, that they're often made of at least two different types of elements. So the difference is that a compound has to consist of two or more different types of elements, right? So here I have H with O. These two are different elements. H with Cl. These two, even though they're combined together, are made up of different elements. So the two definitions are very similar. All compounds are considered molecules, right? So know that compounds fit within the definition of a molecule, but not all molecules are considered compounds, right? They're only considered compounds if it's two or more different elements. And if we broke it down further, if we used a chemical process or a chemical reaction, we can break down these molecules into their individual elements, right? So H2O here can be broken down into just H or hydrogen and just O, oxygen. So that was a recap of lesson 3.1, a little bit clarified. So if we had to draw these, sometimes it takes a while. So it would be much faster for us to represent them as a molecular formula. So a molecular formula is just a formula or like element symbols with the number of each type of elements and the type of elements written in written form, right? So here are examples of different molecular formulas. I want you to first notice the numbers in these, comparing them to the shape of the molecule. What do you think the number is telling you? Go ahead and pause this video right now and see if you can figure out what the numbers are telling you. Okay, so you might notice that next to CO2, there's a number 2, but there's no number next to C, right? And you might also notice that next to O, because there's a number 2, in the shape or the model of the molecule, you see two oxygens, So the numbers below just represents the number of each element you have. Number of each elements, right? So that's what the number means. And we call this bottom number down here a subscript. SUBSCRIPT, subscripts. Now, notice next to C there is no number, but that doesn't mean that there aren't any C's, right? You can clearly see that there is a C or a carbon here, and that means you just have one carbon, right? It's implied that there's only one carbon, so we don't even need to write the number 1. So notice that this formula says KBr, so there's no number next to each element's symbol. So therefore, I only have 1K and 1Br. Right here, I have 2 next to the H and no number next to O. So that should mean I have 2 hydrogens. Right. So here there's 2 hydrogens and 1 oxygen. 1 oxygen shown here. So here there's no number next to C, but there's a 4 next to H. So this means I have 4 hydrogens. 1, 2, 3, 4 hydrogens. No number next to C, so that means there's 1 C or 1 carbon. All right, so the next thing I want you to notice is that how can you tell whether there's a new element in the formula, right? Is it shown by a capital letter or a lowercase letter? So go ahead and look in these formulas again and see if you can tell, how can you tell there's the start of a new element? Okay, so you might notice that every time there's a new element, you should see a capital letter, right? So C counts as one element, O counts as a separate element. I can clearly see them in their own circles in the shape of the molecule. So each time there's a start of a capital letter, that is the start of a new element. So here I have K, B, R. So K is one element. Next to it is a capital letter, right? So here it's capital B, lowercase r. And if you notice on this molecule, Br is together and K is shown by itself. Right? So every time I see the starts of a capital letter, that is the starts of a new element. Let's do one more. So how many elements are on here? You'll notice that there's an H, right? Then a number, another capital letter. So that means this is a new element. So I have H and O, right? These are my 2 different types of elements. So every time you see the starts of a new element in a molecular formula, you should see a capital letter, right? And the third thing I want you to notice is each time how many letters maximum can represent an element. So re-looking at all of these, now that we've separated them into the types of elements, how many letters maximum represent each element? Okay, so you might notice that every single time, all of these are represented by at least one capital letter, right? BR is the only one with 2 letters. So every time we're writing an element symbol, it's represented by 1 to 2 letters, right? Always starting with a capital letter and the second letter always being lowercase, right? So if BR is represented by 2 symbols, the first letter is always capitalized, second letter is always lowercase. Right? So that's how you tell each element represented by their symbol. So let's do some practice problems in the next slide. So my question for these examples is what type of elements and how many of each elements are in these molecules below? So go ahead and pause the video and see if you can identify what types of elements there are and how many there are of each. Okay, so let's check your answers real quick. So here I have C and then the number 6. So that means I have 6 C's. All right, if you know what C is, then it's carbon. But if you didn't know this, that's okay. Totally fine, because we're going to talk about that another time. All right, so then I see another capital letter, H, and the number next to it. So that means here I have 12 H's, or hydrogens, right? And then finally, in this last one, there's another capital letter, and then the number 6 after. So I also have 6 O's, or oxygens, right? So in this molecular formula, I have 6 C's, or carbons, 12 H's, or hydrogens, 6 O's, or oxygens. So doing the next problem, here I have capital M, lowercase g. So this represents one molecule. And then the next letter is a capital B. So this is the start of new elements. But down here, there's no number. So how many mg's would I have? Well, I would only have one mg. For this next one, capital B, lowercase r, that means capital B and lowercase r go together. There's the number 2. So here I have 2 BRs. So here I have capital H. So notice capital H. There's no number down at the bottom. So here I have 1H. Moving on to this one, capital C, this is a lowercase l, so these two go together. C and L, there's no number here, so I have 1Cl. Again, this L is lowercase, that's why these two go together. So here I see 3 capital letters, so there are 3 different elements. There's a C, there's an H, and there's a capital F. Right. Now for the C, I don't see any numbers next to it. So that means I only have one C for this problem. And here there's a number 3 next to H. So I have 3 H's. And then finally for the F, there's no number or subscript down here. So here I have 1F, or 1 fluorine. Right. So hopefully that helps you out. You should be able to identify the types of elements and numbers of elements within a molecular formula at this point.